We now know enough to fully factor some of those polynomials that we couldn't back when we were doing our basic polynomial work. And that's pretty cool. Let's go through the whole process. And in this example, I will tell you that we can fully factor this one using only rational roots. We can get this one as a product of linear factors using only rational roots. Now, this one has 1, 2, 3, 4 terms. We had a method for factoring things with 4 terms. We should try grouping. We should always try the old methods first, because if they work, they're easiest. But let's see. I'm going to try just grouping the first 2 terms and then the last 2 terms. First row, my greatest common factor is x to the 3rd. Second row, it's, what, I think it's 2. Okay, that's no good, right? Because it's definitely not true that 2x times 2 gives me 68. No, that's no good. We're stuck. Let's see. I've tried grouping the 2x with the negative 17 and with the 68. Let's try putting it with the negative 32. I don't think that's going to work either. Right, I've got a 2 here, and well, this is an x to the 4th. And that's not a factor of this. That's no good. We're not going to get anywhere by grouping. Grouping has failed us. When we first talked about factoring, we said, if grouping fails us, wait for more advanced techniques. Here we are at more advanced techniques. So our first step is to apply Descartes' rule of signs. So looking at our original polynomial, we have 1, 2, 3 sign changes, which means that we'll have 3 or 1 positive real root. When we plug in negative x, that's going to reverse the sign of everything with an odd power of x. 2x to the 4th stays the same. Negative 17x to the 3rd becomes positive 17x to the 3rd. Positive 68x becomes negative 68x. And then negative 32 stays the same. Here we have 1 sign change. So we'll have 1 negative root. Okay, we know we're going to have at least 1 positive root, and we might have 3. We're going to have exactly 1 negative root. I'm going to start by looking at positive numbers, because I think I've got more of those. So what are they going to be? My leading term is 2, and its factors are plus or minus 1 or plus or minus 2. My constant is negative 32. Its factors are plus or minus 1, 2, 4, 8, 16, and 32. So what are the possible rational roots? Well, we have each of these numbers over 1, and then we have plus or minus a half. But then any of the rest of these over 2 are things that we already have. So this is the only fraction we've actually got. Everything else over 2 turns out to be an integer. We've already seen it. We're not going to have to deal with a lot of fractions in this problem, which is nice. Let's start by trying some positive integers. I'm pretty much always going to try 1 first. So bring down the 2, times 1 is 2, plus negative 17 is negative 15. Times 1 is negative 15, plus 0 is negative 15. Times 1 is still negative 15, plus 68 is 53. Times 1 is 53. Plus negative 32 is going to be positive 21. Okay, so we have two things. We see that this is not a root, but also we do not have an upper bound because we've got some positive and some negative numbers. Okay, it wasn't an upper bound, so we can try things that are bigger than 1. I'm going to try 2 next, just because it's the next one. Smaller numbers make arithmetic easier. So I drop down the 2. Times 2 is 4. Plus negative 17 is negative 13. Times 2 is negative 26. Plus 0 is negative 26. Times 2 is negative 52. Plus 68 is positive 16. Times 2 is positive 32. 0. Yay! We got a root. By the way, I wasn't just doing that arithmetic in my head. I worked this out earlier. You can absolutely use a calculator for that arithmetic if you'd like. We didn't get an upper bound. We might have more roots that turn out to be greater than 2. But hey, we've got one factor. We got the factor x minus 2. And the synthetic division shows us that the remaining factor is 2. Go down 1 degree from x to the 4th to x to the 3rd, minus 13x squared minus 26x plus 16. We need to factor, then, x minus 2 is linear. We can't factor that at all. But we still need to factor 2x to the 3rd minus 13x squared minus 26x plus 16. This has 4 terms, so we should try grouping again. But that still doesn't work. Now, looking at the rational roots, 32 is no longer a factor of our constant because that's 16 now. So that means that plus or minus 32 are no longer possible rational roots. We've also eliminated 1. X minus 1 wasn't a factor of the original polynomial, so it can't be a factor of a factor. However, 2 could happen again. 2 might have multiplicity. So we will still need to check that. All right, what are we doing now? We're trying to factor 2x to the 3rd minus 13x squared minus 26x minus 16. The possible rational roots are, referring back to the previous page, but eliminating what we eliminated, negative 1, but not positive 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, no longer 32, and plus or minus 1/2. We've still got that one there. Okay, so what should we try next? Well, let's try 2 again. Drop down the 2. Times 2 is 4, plus negative 13 is negative 9. Times 2 is negative 18. Oh, this isn't looking good. Add those together. We have negative 44. Times 2 is negative 88. Plus 16 is negative 72. Okay, well that's no good. We can either continue to try positive integers, or try some negative integers, or try 1/2, but I'm not going to try 1/2 because I would rather not deal with them. Maybe let's try 4 next. Drop down the 2. 2 times 4 is 8. 13 plus -8 is -5. Times 4 is -20. Oh, this is going to still be no good. So that's -46. Times 2 is not -16. So this is not 0. I know for sure that that's not going to be 0. I know I don't have a root, so I don't need to actually find out what I actually do have, because all I care about is whether it's a root or not. Okay. The arithmetic's getting ugly, but I'm going to go ahead and try 8. Hopefully 8 will either give me an upper bound or give me another root. Drop down 2 times 8 is +16, plus -13 is 3. Times 8 is +24, plus -26 is -2, times 8 is 16, negative, and that adds up to 0. All right, 8 is a root. All right, got it in 3 tries. So that means x minus 8 is a factor. My original polynomial then? Well, it had a factor of x minus 2, I found that before, and then the x minus 8 that I just found, and then the remaining factor is a 2, go down another degree, so 2x squared plus 3x minus 2. Oh, the remaining factor has 3 terms, and it's quadratic. Now we can use the AC method. Remember how I said I didn't want to deal with a half? Often we can avoid dealing with fractions in the synthetic division because the last 2 factors, eventually we're going to get down to something quadratic, and we're real good at factoring quadratics. So let's see. AC method. A is 2, C is 2, C is -2, so AC is -4. We want 2 numbers that multiply to -4 and add up to +3. Oh, well, 4 times -1 is -4. 4 plus -1 is +3. So the 2 numbers we want are 4 and -1. Remember, we use that to split up our middle term. So we have our 2x squared, a 4x, a -1x, and a -2. Greatest common factor here is a 2x. We need an x here. We need a -1 here, and a 2 here, and -1 times 2 really is -2. So let's see. We had x minus 2, x minus 8, and then x plus 2 from the AC method, and 2x minus 1 from the AC method. So the roots are 2 we found by trial and error, 8 we found by trial and error, and then that factor is x minus -2, so -2 is a root. And then this factor corresponds to the root +1/2. And notice, just as we predicted, 3 positive, 1 negative. So that's how we factor fully. We try things until we get down to something small enough that the old methods work, and then we use the old methods.